In this video, we're going to review our rules for naming ionic compounds, as well as go through a few examples practicing naming some ionic compounds. First rule is to always write the name of the metal first. This is going to be the element that appears first when looking at the compound formula. Do not change the name of the metal in any way. If it is a transition metal, it will have more than one possible charge. The charge will need to be indicated using a Roman numeral inside parentheses directly following the name of the metal. Next, you will write the name of the nonmetal. You will need to change the ending of the nonmetal to IDE. Do not use any prefixes when naming ionic compounds, and do not include the subscripts, which are the small numbers in the lower right hand following an element in the formula, in any way. In our first example, we have sodium and chlorine. So to write the name, it is just sodium. And then chlorine needs to be changed to chloride. And there we see that IDE ending. Our next example, we have lithium and fluorine. So this is going to be lithium fluoride. K2S, we have potassium and sulfur. You think back to our rules, we don't do anything with that subscript 2, so this is just going to remain potassium. And then the sulfur is going to become sulfide. Up at the top we have barium and iodine. This will become barium iodide. Sodium again, and now we have oxygen, so this is going to be sodium oxide. And we have magnesium and bromine, so magnesium bromide. I cleaned up my handwriting on a few of those, and I'll pause for just a moment in case you wanted to check your work. When writing the formula for ionic compounds from the name, the first thing I like to do is write the symbols. So we have lithium and bromine. The next thing above the name would be to identify their respective charges. So lithium has a charge of +1 because it's in column 1A. Bromine has a charge of -1 because it's in column 7A. The next thing you can do is crisscross those charges, and they will become the respective subscripts. So we have lithium 1, bromine 1. We don't typically write out the ones, so we would just rewrite this as LiBr for lithium bromide. Looking at aluminum sulfide, Al for aluminum, S for sulfur. Aluminum is in column 3A, so it's going to have a charge of +3. Sulfur is in column 6A, so it's going to have a charge of -2. Now we can crisscross. The 2 is going to go with aluminum, the 3 is going to go with sulfur, and we can rewrite this as Al2S3. Magnesium oxide is magnesium and oxygen. Magnesium is in column 2A, so it's got a charge of +2. Oxygen is in 6A, so it's got a charge of -2. We crisscross, so it's Mg2O2. Now, we always want to write the formula in its simplest version, so because these are both 2's, we can say that they're going to reduce. And so for every 1 magnesium, there's going to be 1 oxygen. And we don't write the subscript 1, so it's just MgO. Aluminum fluoride, we have aluminum and fluorine. Oops, forgot the L. Aluminum we already identified had a charge of +3. Fluorine is in 7A, so it's got a charge of -1. We're going to crisscross 1 and 3, and our new formula is going to be AlF3. barium and chlorine, BaCl. Barium is in column 2A, so it's going to have a charge of +2. Chlorine is in 7A, so it's going to have a charge of -1. We can do our crisscross. Barium will have a 1, Cl will have a 2. So our new chemical formula is going to be BaCl2. Now, looking at a couple of chemical formulas that have transition metals, this means that they have a variable charge, so we're going to have to identify what that charge is. So Pb stands for lead. We know that it's going to have some Roman numeral to represent that charge, and then we have Cl2, which is chlorine. Or excuse me, it's chlorine, but we will be changing it to chloride. Now, chlorine has a charge of -1, but there's 2 chlorines, so we're going to multiply by 2, which is going to give it an overall charge of -2. So therefore, our Roman numeral that we're going to represent, because there's only 1 lead there, remember if there's no subscript that represents a subscript of 1, is going to be lead 2 chloride, and we're going to use a Roman numeral 2. I'll just split this in half for a second. Hg is mercury. So mercury, parentheses, because we're going to need to identify the charge. O is oxygen, so we're going to change that to oxide. Now, oxygen has a charge of -2, but there's 2 oxygens, so -2 times 2, which is going to give us an overall negative charge of -4. So in order to be balanced, because there's only 1 mercury atom present in that compound, this is going to be mercury 4, and the letter 4 is going to be IV. Now we're going to go in the opposite direction. We have the names of some ionic compounds, and we need to write the formula. Just like before, we can do that crisscross technique. So in our first example, we have lead 2 oxide. So if it's lead 2, that Roman numeral 2 is going to indicate that we have a charge of a +2. And oxygen, we know, has a charge of -2. So we'll write out lead, which is Pb. Oxygen is O. We're going to crisscross. 2, and as we stated earlier, we cannot have, or excuse me, we always want to simplify our subscripts, so this is just going to be PbO. Looking at chromium 3 chloride. Chromium 3, so it has a charge of +3, and chloride, or chlorine, which has a charge of -1. Chromium is going to have a symbol of Cr. Chlorine is Cl. We can do our crisscross. So our formula is going to become CrCl3. Lastly, we have cobalt 3, so +3 oxide. Oxygen has a charge of -2. So we have CO for cobalt, O for oxygen, crisscross. 3 is going to go with the oxygen, 2 is going to go with the cobalt, and when we rewrite it to clean it up, we've got cobalt, little o, cobalt, 2, oxide, or O3. Thanks for watching, and hopefully it helped.